Hello, Math 6 class, and this is our first lesson to be taught online. So I tried to make this to be like a classroom, so I decided to use a whiteboard. Today we're going to learn the first lesson. Okay, our first lesson is 3.2. Okay, on 3.2 we learn a new things how to represent degree. So normally, how to represent angle. So normally we use a degree for angle, but now we're going to use a radians, okay? So you're going to learn how to convert degree to radians. And we learn how to compare also. So when you go degree to radian, our goal is to take away the degree sign. So you're going to multiply pi divided by 118 degree, and when we come back we do the opposite, reciprocate it, so we multiply by 118 degree divided by pi. And I remember last time I gave you guys formula also, so just to remind you for that. The last thing so why do we have to learn radians? Okay, that's the one thing is useful when we use for an application problems. So for instance, if I have a circle, okay, and I'm gonna cut a piece out like a piece of pie, and let's say this is my center, and this is my angle here, and this is my radius, and this is my arc length. Okay, this is length here, this length here, we use S. If I want to find this angle, and my formula will be theta equal to kind of like a sine, okay? Opposite to, in the opposite one to the one next to it, okay? And then it's S over R. For this angle, we're going to use a radian to represent that. So this theta is in radians, it's RAD. So that's the reason why I want to learn radians. And so now let's see the examples. Okay, here's example number 8. We are given R is equal to 3 inch and S equal to 12 pi. Okay, S equal to 12 pi. We want to find out what theta equal to, so theta will equal to S over R by the formula, so it's S over R. So that's equal to 12 pi divided by 3, and which is equal to 4 pi. Okay, so pi means it's a radian answer. So that's how we use this one. Now, we're going to see another example, okay? We are looking at example number 13. So I'm going to erase this one. And we're going to go to example number 30. On number 13, they said there's a clock. Okay, here's a clock. And they said throw how many radians does the mini hand of the clock turns during a 35 minutes period. So the handle of the clock, okay, let's say it's a handle, a mini handle, and then turns about 35 minutes, okay. So 35 minutes, total turn 35 minutes, so this is the same handle. So total turn, okay, 35 minutes. And they want to know the how many radians this theta should be. Now we think about it. When we turn the whole clock one time, okay, that's one round. That's a 60 minutes, right? And 60 minutes, that's what? The whole circle is represented by 2 pi. So 60 minutes, they go 2 pi. Now you're at 35 minutes. How many pi do you go? Okay, that'd be theta. So we're gonna make like a proportion here. Okay, we're gonna divide here and then we put equal and divide here. Our goal is to find theta. So theta, we do a cross multiplication. Okay, theta times 60 minutes times by 60 minutes equal to 2 pi times by 30 minutes. And we're going to divide 16. Okay, divide by 16 here, divide by 16 here. So your theta will equal to, now we're going to reduce this. Okay, that's a 13 here. Okay, and divide by 5, this is 6. Divide by 5, 7. So it's equal to 7 pi over 6. And that's how you do the problem. So that's for point number 30. And unfortunately, I couldn't answer question during the video. So if you have any question regarding any example, you just take a picture of it and post on the discussion board if you can. And then I will answer it once I've seen it. Other classmates can also help. Okay, so please help each other on the discussion board. And the last one is we're going to learn how to find the exact solution. Okay, exact solution or exact value for trigonometry. Okay, for trig function. Okay. And let's see point number 15.8. We have a cosine 5 pi over 3. We want to know what this is equal to. Okay, so now let's recall. We know that 0 degree, 13 degree, 45 degree, 16 degree, and 19 degree. The chart I wrote on the board before, and this is just what 0. This is what power 6. Remember I said 3 and 6 are go as a pair. So this is 0. This is power 6, and this is power 4. Power 3 and power 2. So first we have sine, okay, cosine, and then tangent and cotangent. So this is a 0, 1 over 2, square root 2 over 2, square root 3 over 2, and then square root 4 over 2, so that's a 1. And the cosine will go the opposite, so it's a 1. Square root 3 over 2, square root 2 over 2, 1/2, and then 0. And then tangent divide this number, so it's a 0, 1 over square root 3, 1, and this is what? Square root 3 is undefined. And this is just opposite, so first we are undefined here. And then I'm square root 3, I'm not going to write the whole word, I don't have enough room, so 1. And it's a 1 over square root 3, and that's a 0. That's what I gave out last time. Okay, that's what we give out. And we're going to use it. So now cosine power 3, so what is this? Okay, so first of all, we're going to think about this, okay? And I teach you a fast way to look at this. So this put 0 here, okay? And so there's 3 here, means you divide this thing by 3 parts. So 1, 2, so 1, 2, 3. And then you're going to take 5 of them. So you go 4, okay? So 1, 2, 3, 4, 5, okay? So you're going to take 5 parts of it, okay? So it means you're right here, right? So this pi you didn't take, the pi you don't take is your reference angle, okay? So that is your pi over 3, okay? So therefore, you're going to put this for cosine in quadrant 4, there's a positive here. So cosine is a positive on the right and negative on the left. So this is a cosine power 3. And cosine power 3 is right here, right? So that is what? 1/2. Okay, so that's how you do these problems. And let's try let's try number 16. Okay, so I'm going to keep this one here, and then I just erase this one. So I can have enough room. Okay, this is problem number 60. And we are doing cotangent power 4. Well, cotangent power 4 right here, okay, just equal to 1. So that's pretty straightforward. And the last one will be number 16(2). Okay, number 16(2). Sorry, I had to erase it, so I have enough room. And we have cosecant 3 power 2. And this one we do the same thing. We're gonna break this one first and then break 2 parts. Okay, 2 means you're gonna break 2 parts. So you're gonna take 3 of them. So you go 1, 2, 3, and then this is a 3 power 2. Well, we know cosecant is same as what? Reciprocal for sine. Okay, so you're gonna look for sine power 2 first and then flip it. Okay, so this is same as 1 over sine 3 power 2. Well, this becomes the reference angle. Okay, so that's the part you don't take it, that's your reference angle. Okay, right here. So this is equal to power 2. Okay, so that means that we look for sine power 2, which is what? 1. Okay, so 1 over 1, that's is equal to 1. So that's how you do 16(2). So the part you don't take it, remember, that will be a reference angle right here. Okay, so oh, I forgot the negative sign, sorry. So sine 3 power 2 is a -1, so this is a -1. Okay, sorry about that, I forgot the sign. And because sine takes a negative here and positive here. So that's for 16(2). And let's look at 16(4). So 16(4). They ask for secant 5 power 6. And we do the same thing, okay? They say 6, that means you're going to divide this picture, divide the 9 by 6 part. Okay, divide this part by 6. So we come here, so we go, this is 2, 1, 2, 3, 4, 8, I need more. 1, 2, 3, 1, 2, 3, 4, 5, 6, divide by 6 of them. And you're going to take 5 of them. Okay, you're going to take 5 of them. So you're going to take 1, 2, 3, 4, 5. Okay, the one you don't, so this will be power 6. The one you did not take is a power 6, and that is your reference angle. And so secant is equal to 1 over cosine 5 power 6. And that's your second quadrant, so cosine is a negative, so same as a 1 over negative cosine power 6. You take the reference angle. Well, cosine power 6 right here, okay, power 6, cosine is square root 3 over 2. You're going to flip that, okay, you basically flip this one, okay, because this is a cosine power 6 equals square root 3 over 2, and you're going to take 1 over it, so you flip this number, become -2 over square root 3, and you can just leave your answer like that. Okay, you don't need to rationalize it if you don't want to. And the last number is number 78. And I'm going to erase this as a more room, because we don't need to use yet. Okay. Number 78. And what we are given is the expression. Okay, we are given negative 1/2 sine 3x plus power 6. And they want to find x equal power 6. They say if for x equal power 6, what is expression going to equal to? Okay, so you just need to put power 6 inside here, put it right here, okay, and then to evaluate the expression. So that becomes negative 1/2 sine 3 times power 6 plus power 6. Do not reduce here because you want to keep the same LCD. So that's equal to negative 1/2 of sine. This is basically 3 over 1. So that's a 3 pi over 6 plus power 6. Once they are same LCD, you can add the top together. So it's a negative 1/2 sine 4 power 6. Reduce 2 and 3, so that's equal to negative 1/2 sine 2 power 3. So because sine 2 power 3 is not from here, so therefore we have to look for the reference angle again. So we do the same thing how we did it. So when there is 3 here, so that means you divide this 9 by 3 parts. 1, 2, so 1, 2, 3. And you're going to take 2 of them. Okay, you take 2 of them. So that means you're going to take up to here. Okay, the one you don't take, okay, the one you don't take is this one you don't take, right? So you don't take this one, that's your reference angle. Okay, so that's a pi over 3. And because it's for sine on the top, it's a positive, so that means that this is same as negative 1/2 of sine power 3. Okay, and sine power 3, let's look at it right here. So it's a square root 3 over 2. So equal to 1/2 or negative 1/2 times by square root 3 over 2. Okay, so that becomes, I'm going to continue here. So it's a negative square root 3 over 4. And so that's the answer. Okay, so when you see in radian, okay, you don't need to convert to the degree to do the problem. You can just draw the line how I did here, and that's easier for you. You just need to get used to seeing the radians. Just a different way to represent the angle, the unit for the angle. Okay. And the last one we're gonna do is number 90. Okay, that's the last one I'm gonna do for this lesson. Number 90. We are given y is equal to cosine x minus, oh, I'm sorry, I looked at the wrong problem. So y is equal to sine x plus power 4. And they want to evaluate when x equal to field number. Okay, they say x equal to negative power 4, 0, and power 4. Power 2 and 3 power 4. So I'm going to pick one of them to do. So I just put x equal to power 4. And we just put the number inside here. Okay, so y is equal to sine power 4 plus power 4. And then because they only have same LCD, so that's kind of nice. I just add the top together. So 1 pi plus 1 pi 2 power 4. So that's equal to sine power 2. And sine power 2 is right here, just equal to 1. Okay? And so that's how you do this session 3.2. So be sure to do your homework.